right, let's continue talking about our chapter 5 material. Now we're going to go from our exponent rules that we spent the first part of this chapter on to polynomials. So this first section is going to be on adding and subtracting them. And then our next section, when we start multiplying and dividing, is where we're going to start to see our exponent rules come into play. So let's go ahead and just kind of review some terminology and some vocab for polynomials. So an expression, and we're just going to look at an example here and kind of label parts. Remember, an expression doesn't have an equal sign. It's just a list of terms joined by operations. So let's say we have the expression 4x cubed plus 6x squared plus 8. So with this expression here, this 4 in the front here is called a coefficient. Remember, that's just the number in front of a term. For this constant, 8 is the coefficient. And then the 6x squared is an example of a term. So remember, terms are separated by addition and subtraction. So we have 3 terms here. And as long as there's multiplication and division within that term, that's fine. It's still a single term. It's not until you introduce addition and subtraction that you have separate terms. And then this 8 here at the end is the constant. It's not changing. There's no variable attached to it. So first thing I want to go through and do is just identify some coefficients, because this is going to be really important for when we add and subtract these in a second. So identify coefficient. Number 1, let's say we're given 7x. Coefficient here is just the number in the front, so it's 7. Number 2, negative 3pq. Even though we have 2 variables here, we still have 1 number in the front, and you want to make sure that you include that negative. So our coefficient is negative 3. Number 3, negative y. What number's in front of this y that we don't actually see there? There's always a 1, so this one's a negative 1. And then finally, same thing with this one, we have z to the 4th. There's no number in front that we can actually see, but we have 1 of these terms, so the coefficient is a 1. All right, so now what we're going to be doing in order to add and subtract polynomials is combining like terms. And so this is something we've seen before when we've simplified, and this is going to be really similar to what we've done. Combining like terms, all we're going to do is add the coefficients. And remember, we're not multiplying these terms, so we're not going to be changing any exponents, because exponents are used for multiplication. All we're doing is adding or subtracting the terms so the exponents stay the same. So let's go ahead and look at some examples. And so for these examples, we're told to simplify, then write in descending order. So descending order is something we won't always be asked to write it in descending order, but we're going to practice it with these just so we know what it looks like. Descending order means that our exponents are going to go from highest to lowest, or the exponents decrease, and then the constant goes last because it doesn't have a variable attached to it. So let's go ahead and just look at a couple of these. This is again review, so I don't want to spend too much time on this. Let's say we're given 5x to the 4th plus 7x to the 4th. For this one here, they're both x to the 4th, so they're like terms. So if we combine these, then we have 12x to the 4th. So again, just like we've seen before, combine those coefficients, keep your variable. And this is only one term. So this is descending order because there's only a single term. Let's try a couple more of these. Let's try 9pq plus 3pq minus 2pq. So again, we have, make sure they're all like terms, so pq, pq, pq. And just so you recognize this, if they were switched around, so it was qp, this is still the same term, same variable, or not same term, same, they're like terms, same variables raised to the same exponent. So we can combine all of these. 9 plus 3 is 12, minus 2 is 10, pq. And normally we'll write those in alphabetical order, so I'm going to leave the p in front of the q. Okay, let's try one more where, actually we'll try two more. So this next one we're given r squared plus 3r plus 5r squared. So if I just look at the r terms first, we only have one, we have a 3r. And then r squared plus 5r squared, we have 1 plus 5 is positive 6r squared. This is still technically correct, but to write it in descending order, we want to flip those around. So the highest exponent goes first. Just make sure the sign that is in front of the term stays with it. So this is a positive 6r squared, so 6r squared, and then positive 3r, so plus 3r. There are two terms, so you still need addition or subtraction in between. It's just going to depend on the sign. So this is one that's a good example of writing in descending order. All right, and one last one. 3x to the 4th minus 3x squared. So for this one, we both have 3's in the front, but we have an x to the 4th and an x squared. There's nothing we can do here, and it's already in descending order. The x to the 4th comes before x squared. So I'm just going to say already simplified. All right, so now let's look at a little bit of terminology again before we get into some more examples of adding and subtracting polynomials. Let's talk about what a polynomial is. And this is a lot of what we've already seen. All of those that we just looked at were polynomials. So a polynomial is a sum of finite terms, so it's not going to go on forever, of the form ax to the n. And so this is just saying some coefficient a and then x to some exponent. And we're going to say that n is positive and a whole number. So it's a positive whole number, which just means we don't want any fractions there, otherwise it's not a polynomial. And we don't want any negative exponents either. And it's also written in descending order. So again, this is something that if the question doesn't specify, then you can technically leave it out of descending order. But it's always best to put it in descending order just whenever you can. So an example of a polynomial is something like we've seen before. We'll just say 16x to the 8th, not comma, we want to plus or minus in between. Let's say minus 5x to the 6th plus 3x cubed minus 10x plus 4. So this is an example of a polynomial in descending order. So if we look at this, the exponents decrease and the constant is last. So some examples of things that are not polynomials, just so you can kind of see the difference. something like 2x cubed minus x squared plus 4x to the negative first. This one is not a polynomial because of that negative exponent. We can't have negative exponents in our polynomials. Another example would be something like 2x squared minus 3x to the 1/2. This one is not a polynomial because we only want whole number exponents, which 1/2 is not. Couple more term or definitions here before we get started with some more examples. The degree, and we have two different types of degrees here. We have degree of a term, and then we're going to have degree of a polynomial. So the degree of a term is just the sum of the exponents on the variables in the term. And so this is looking at just a single term, so something like 2x squared. The exponent here, there's only one is a 2, so the degree of this term here would be 2. We don't care what the coefficients are, we're only looking at the exponents. The degree of a polynomial, we have to know how to find the degree of a term first, because the degree of a polynomial is the highest degree of any term in that polynomial. Okay, and one last set of definitions here. Types of polynomials. We have 3 different types, and then if it's not one of these 3 types, we just call it a polynomial in general. So the first kind is a monomial. And so a monomial is a polynomial with one term. So if you just have a single term, it's polynomial because it has a positive whole number exponent on the term, then it is a monomial. A binomial, if you can guess, like a bicycle, is going to have 2 terms. Oops. And then finally, a trinomial has 3 terms. And again, if it has 4 or more terms, we're just going to call it a polynomial. Poly just means many. All right, so for this first set of examples with polynomials, we're going to go ahead and do a few things with this one. Let's go ahead and first simplify. So in order to identify what type of polynomial it is and the degree, we're going to have to simplify. Then give the degree, and we're talking about polynomials, so it'll specify if it wants the degree of a term, but since we're looking at polynomials, we need the degree of the polynomial. And state whether it is a monomial, binomial, trinomial, or none of these. Okay, so number 1, let's go ahead and look at 3x squared plus 2x minus 4. So to simplify, we need to check for like terms. We have an x squared, an x, and a constant. No like terms, so we can't simplify. So this is our simplified form here. The degree, so if we look at the degree of each term, this degree here is 2 because that's our exponent on this term. The degree for this one, our exponent is 1. the degree of any constant is 0. You can think of that like it has no variables with it. And that's also because x to the 0 is 1. 4 times 1 is still 4. So there's still technically a variable there, but we don't write it because it's not completely simplified unless we evaluate that 0 power. So our highest degree of any of these terms is 2. So our degree is 2. And then the type of polynomial, since there is 1, 2, 3 terms, we have a trinomial. All right, let's try some more of these. Let's try x cubed plus 4x cubed. All right, so first we want to simplify. X cubed plus 4x cubed, 1 plus 4 is 5x cubed. So I'll box that, that's our simplified answer. We only have one term, so that has to be the degree of the polynomial, and the degree of this term is just 3. And then finally, is this a binomial, monomial, binomial, trinomial, or none of them? Well, it's a single term, so it's a monomial. All right, I'm going to go ahead and put up 2 more here if you want to try these before I write up the answers. I would definitely recommend doing that. Number 3 is x to the 8th minus x to the 7th plus 2x to the 8th. So just remember to simplify that one first. And then number 4, 6ab minus 7ab plus 3ab. And again, simplify first. The degree of number 4 is a little trickier. Just remember that you need to find your the sum of the exponents on each of those terms, or a single term, depending on what you have left when you simplify. So number 3, simplifying, we can go ahead and combine the first and the last terms. So we get 3x to the 8th minus x to the 7th. The degree of this polynomial, we want the highest degree. The degree of this first term is 8. The degree of the second term is 7. So the highest is 8. And then finally, the type of polynomial we have here, since we have 2 terms, we have a binomial. And finally, the last one here. These have an a, b in every single term. So we can actually combine all of these. 6 minus 7 is -1, plus 3 gives us 2ab. So the degree of this one, you have to be a little bit more careful. Anytime you have more than one variable, the degree of the term is going to be the sum of the exponents. So the exponent on this a is 1, the exponent on the b is 1, so the degree of this term is 2. So it's the sum of the exponents. And note that that's only because we had a single term. If we had another term there, you don't want to add up the exponents on every single variable throughout the whole thing. We didn't do that in these up here. It's just on each individual term that you have to add up the exponents. And then finally, we have one term again, so we have a monomial. So if we would have had something with 4 terms, that would have been when we put none of these, because it doesn't have 1, 2, or 3. It has 4, which is none of those kind of special polynomials. All right. Now we're going to do a little bit of evaluating, which is something we've seen before, so we'll just do 1 or 2 of these. So we're told to evaluate 2x cubed plus 8x minus 6, 4, and then we're given two different values. The first value is x equals 4, and the second one is going to be x equals -1. So let's go ahead and first of all, remember what it means to evaluate something. Anytime you're told to evaluate, we want to take this variable or this number for x, plug it in wherever we have an x in our polynomial, and then just simplify it down. So we have 2x cubed. So remember, this is 2 times x cubed. So 2, and what I'll usually do, this is kind of the safest way to do it because you're going to have negatives to work with sometimes. Always plug your number into parentheses. It's just going to avoid some kind of potential mistakes, especially when you have negatives. Plus 8 times x, so 8 times 4, minus 6. So remember, simplifying, you want to do exponents first. So 4 cubed is 64, so 2 times 64, plus, I'll do all of the multiplication in the next step. So now let's multiply. 2 times 64 is 128. 8 times 4 is 32, so plus 32, minus 6. And then if we go from left to right, 128 plus 32 is 160, minus 6 is 154. And that's all you're doing, just plugging it in, simplifying down until you get a single number. So let's go ahead and try it with the -1. So again, 2 parentheses -1 cubed plus 8 parentheses -1 minus 6. And then let's again evaluate exponents first. So we're going to have 2 times -1 times -1 times -1 gives us -1. Plus 8 times -1 minus 6, and I don't know why I put a parenthesis at the end here. Okay, so now multiplication, 2 times -1 is -2, plus 8 times -1 is -8. Again, you could just put -8 there if you wanted, and then minus 6. And then if we combine -2 plus -8 is -10, minus 6 is -16. All right, so now let's get into actually adding and subtracting some polynomials. And so we're not going to do a ton of practice with these either, not as much as we'll do when we get into multiplying and dividing, just because adding and subtracting is just like we've already been doing. It's just combining like terms. It's just going to look a little different at first. So adding polynomials, we're just going to combine like terms. And so all we're going to do is just jump into some examples here. We're told to add, and it's implied that you always want to simplify at the end. So number 1, and these can be written in a couple different ways, so we'll take a look at both ways they can be written. This first one, we have 4x cubed minus 3x squared plus 2x, and then below that we're going to do vertical addition, 6x cubed plus 2x squared minus 3x. So if you like having it set up like vertical addition, you can always rewrite the ones that they give you as a vertical addition problem. You just have to make sure that your like terms always add up, or line up, sorry. So x cubes here, x squareds here, x is on the right. If we didn't have an x squared term, this part here would just be blank. Would just have the 6x cubed here and the -3x here. Let's go ahead and start adding these. So just like regular addition, I'm just going to go from right to left. So 2x minus 3x, just combining our like terms, we get negative 1x, or negative x. Negative 3x squared plus 2x squared is another negative x squared. And 4x cubed plus 6x cubed is 10x cubed. So again, the big thing to remember here is that you always need addition or subtraction in between. So if one of these added up to a positive 1x, then we would have had a plus x instead of minus x here. But that's it. That's all we have to do for these. Let's try a few more. So this next one's written differently. This one's written as x squared minus 2x plus 5 plus, and then in parentheses, 4x squared minus 2. So now for this one, if you wanted to write this as vertical addition, you could. I'm going to write it down and then I'll erase it so I can put my work here. But all you would do is you'd put the 4x squared here. We don't have an x, but I'll put the minus 2 over here. And then you would just add straight down vertically. Make sure you bring down this negative 2x because there's technically a 0 here, and if you add 0, that stays the same. But we'll see another one like that in a second. Let's go ahead and do this one horizontally. So what we're going to do, we don't need to get rid of these parentheses because we're just adding. All I'm going to do here is I'm going to combine like terms. So x squared plus 4x squared is 5x squared. Negative 2x doesn't have anything to combine with it, so I'm going to bring it down. And then 5 minus 2, or 5 plus negative 2, is positive, so plus 3. Again, just combining like terms. All right, let's try another vertical addition problem. 2x to the 4th minus 6x squared plus 7 plus negative 3x to the 4th plus 5x squared. Actually, let's make that an 8x squared plus 2. All right, so our like terms are lined up. Let's go ahead and add straight down. So 7 plus 2 is 9. Positive, so put a plus sign in between. Negative 6x squared plus 8x squared is a 2x squared. Positive, so put a plus. And then 2 minus 3 is negative 1x to the 4th, or negative x to the 4th. All right, now let's go ahead and try one more with the horizontal addition. In parentheses, 3x squared plus 4x plus 2 plus 6x cubed minus 5x minus 7. So I'm going to go ahead and write this answer down in one way, and then I'm going to put it into descending order afterwards, just in case the problem specifies that it wants it in descending order. So I'm just going to work my way from left to right. We have a 3x squared, nothing to combine it with, so I'll just bring it down. 4x minus 5x is negative x. 2 minus 7 is negative 5. And the reason why I like doing these underlines is because you can see what you've combined and what you haven't. We still have a 6x cubed. We can't just leave that off of the answer. And we're adding 6x cubed, so we're going to put plus 6x cubed. So this here is technically correct. But to put it into descending order, we just want to make sure it goes from highest exponent down to the constant. So I want to put this 6x cubed in the front. And then positive 3x squared minus x minus 5. So again, if they ask for descending order, this is what you'll put. Otherwise, the other answer is completely fine. Okay, so adding them, just combining like terms. Subtracting polynomials is almost exactly the same. We're just going to have one extra step, and this is going to be really similar to what we saw way back in chapter 1 when we were adding or subtracting integers. So if you recall, when we're looking at integers, when we have subtraction, so let's just say x minus y, this is the same thing as adding the opposite. So remember, we can change this to, I'm going to rewrite x minus y. This is the same thing as adding the opposite, so x plus negative y. And a slightly better way of writing it, because we're going to look at polynomials, so we're going to have x plus negative y in parentheses. And so what we're going to do is our goal is to make it look like an addition problem, because that's the easiest way to do it, so you don't mess up on signs. So we want to keep the first polynomial. Notice how that x didn't change when we were changing it to adding the opposite. We're going to change it to addition. And then we're going to change the signs of the terms in the second polynomial. That's where our adding the opposite comes into play. We're going to have the opposite of all of those terms in the second polynomial. All right, so let's go ahead and look at a couple of these. And again, we're just told to subtract. It's assumed that we know to combine like terms to make sure it's simplified. Number 1, in parentheses, we're given 3x minus 8 minus, in parentheses, 5x minus 9. So right now, if we were to go ahead and subtract, you'd want to be really careful with your signs. This is why it's easiest to change it to adding the opposite, because if you notice, for the constants here, we have 8 minus negative 9. So it makes it a little uglier if we leave it like that, because you have to deal with the potential double negative. So to avoid that, what we're going to do is we're going to keep this first one the same, change this to addition, so we're going to add, and then the opposite. So change both of those signs. And now we can go ahead and just add these two, just like we were just doing. So 3x and a negative 5x is negative 2x. Negative 8 plus positive 9 is a positive 1. And that's it, just combining like terms. The big thing here is remembering to change all of the signs in the second polynomial. That's probably the biggest mistake, is just changing the first one. You can kind of think of it like distributing that negative in if you want to, but there still needs to be a plus sign in between. All right, let's try one of a little bit longer problem. 14y cubed minus 6y squared plus 2y minus 5 minus 2y cubed minus 7y squared minus 4y plus 6. All right, first thing I'm going to do is change it to adding the opposite. So we're going to add the opposite of each of these. So the 2y cubed became negative, 7y squared is positive, 4y is positive, the 6 is negative. And then let's combine like terms going from left to right. So 14y cubed plus a negative 2y cubed is 12y cubed. Negative 6y squared plus 7y squared, negative 6 plus 7 is positive 1y squared. 2y plus 4y is positive 6y. And negative 5 plus a negative 6 is negative 11. All right, now let's take a look at a couple that look a little different than what we just saw. This one's written in word form, so we're going to have to go ahead and write it out with subtraction looking like one of these. We're just going to have to be careful on the order. So we're told to subtract negative 3y squared plus 4y plus 6 from 7y squared minus 11y plus 8. So we're subtracting this first one from the second polynomial. So if you remember with the ordering here, since we're subtracting one from the other, the one that we're subtracting from is going to go in the front. So we're going to have 7y squared minus 11y plus 8. And then we're subtracting this other polynomial from that. So minus negative 3y squared plus 4y plus 6. We've got our setup. Now all we have to do is add the opposite and combine like terms. So add the opposite of all of these. Combine like terms. 7y squared plus positive 3y squared is 10y squared. Negative 11y plus negative 4y is negative 15y. And 8 plus negative 6 is a positive 2. All right, now let's just do two more of these. I want to take a look at a vertical subtraction problem. So this is another thing you can do if you really like this vertical subtraction setup. You can always rewrite these in this form. And if you don't like it in this form, you can always go back to the ones we were just doing. So we're given 4y cubed minus 16y squared plus 2y plus 1 minus 12y cubed minus 9y squared minus 3y plus 16. All right, so again, if you wanted to, you could write these horizontally. You'd have your first polynomial minus the second one. You just keep it in parentheses. If you like it that way, you can totally go ahead and switch it around. For this one, I'm going to keep it as vertical subtraction, and we're going to do the same thing that we did in the horizontal subtraction. We're going to add the opposite, and we're going to add the opposite on the one that is next to the subtraction sign. So we're going to change this to addition, and then right next to this, change all of the signs. So we have negative 12y cubed, positive 9y squared, positive 3y, negative 16. And now it's addition, so we're just going to add straight down. So 1 plus negative 16 is negative 15. 2y plus 3y is 5y, and it's positive, so plus. Negative 16 plus 9 is negative 7y squared. And 4y cubed minus 12y cubed is negative 8y cubed. Always put those pluses and minuses in between, especially, it's not as easy to forget when you have a negative because you're always going to put that negative there. The positive ones are where you need to remember to put the plus sign in between. Okay, let's go ahead and try one more. This one's just a little bit longer. So this one we're given, in parentheses, 6p to the 4th minus 8p cubed plus 2p minus 1 minus negative 7p to the 4th plus 6p squared minus 12 plus p to the 4th minus 3p plus 8. Okay, couple different ways to do this one. We have 3 different polynomials to add together. Think of this just like numbers. If we had, let's say 3 plus 2 plus negative 1, one way we can do this is we can say 3 plus 2 is 5, rewrite that, plus negative 1, and we get 4. Or we can go straight from this step, add them all together, and go straight to the 4. So it just depends on if you want to break it up or if you want to do all 3 of them at once. I'm going to break it up just to show you that way, but if you wanted to go straight from this first step to the last one, totally fine too. One thing we do have to do, because we have subtraction, change it to adding the opposite, just for the terms inside the polynomial next to the subtraction. So we're going to add the opposite of all of these. The other one's addition, so we can leave it. And now I'll combine the first 2 polynomials first. So 6p to the 4th plus 7p to the 4th is 13p to the 4th. Negative 8p cubed. We don't have an 8p or p cubed here, so I'm just going to bring down minus 8p cubed. 2p. There isn't a p term here either, so plus 2p. And then minus 1 plus 12 is a positive 11. Don't forget the one that you didn't combine yet. So this negative 6p squared, I'm going to leave it as just a negative 6p squared without the plus sign. Those are the first 2 combined. We could have combined all 3 of these at once, but now I'm going to add on that last polynomial, p to the 4th minus 3p plus 8. So we have 13p to the 4th plus 1p to the 4th is 14p to the 4th. Negative 8p cubed, we don't have another of those, so I'll just bring that one down. 2p minus 3p is negative 1p. 11 plus 8 is 19. And don't forget the one that we didn't add, so negative 6p squared. Okay, so again, this is technically correct. To put it into descending order, I'm going to put our highest exponent and just kind of decrease there. So 14p to the 4th minus 8p cubed, and then we need our p squared, so minus 6p squared minus p plus 19. If you would have just added all of the terms together, so 6p to the 4th, so 6 plus 7 is 13, plus 1 is 14. That'll get you straight down to this answer, but it's up to you if you want to break it down into 2 steps or 3 steps, or if you want to just do it in 1. All right, so next section we'll be taking a look at multiplying polynomials. It's a little bit faster. If you remember FOIL, we'll be using that and something called the box method. And then 5.6 is also more multiplication. It's just going to be some special product.